My name is Montrial Harrell. Most people call me Monty, just because they can't chew up my first name. So they'll call me Montel, especially see spelling. I always say, blame it on my mom. It was me. Yeah, you would. Okay. So what I'm going to talk about today is Amazon Nova 2 Summit. So we're just going to talk about but not get into it too deeply because, to be honest with you, it's a pretty complicated subject running through it. So I'm just going to try and give you enough information about it so that you can understand it, but also hopefully it'll inspire you to kind of play around with it and test it out. Okay? Sure. So I'm basically just a data guy, God voice DI. So I've been basically in data, database engineering, architecture, database structures, you name it, I've done it. Reporting, engineer, all that stuff. So I've basically been in data for probably about, got to date myself, about 30 years. So, so I'm a founder of Montrial Consulting. That's the company that's based here in Indianapolis. So we do a lot of stuff from basically database infrastructure, database maintenance, database engineering, like all that stuff. So I've basically been kind of working with AWS, certified AI practitioner, solutions architect, cloud practitioner, but I kind of got inspired to kind of start working with Nova side too because I started going to the gym. They said I'm just overweight, fat guy, so I decided, hey, I need to go to the gym. So I got a trainer. My trainer is actually really great, works really well. But my trainer likes to basically kind of concentrate on what you're working on. So he's not the type of guy to keep up with weights that you did, how many reps you did. You know, it's time for you to move on or anything like that. So I was looking for a application that would allow me to do that, but also not have me take my focus off of actually doing the actual weight training. So what I hate is basically I'm doing a rep, and I got to pick my phone up, type in what I think. That basically to me breaks my rhythm. It also gives me a chance to kind of rest and be lazy. So I wanted an application that would actually help me to basically just, I can tell it what I'm doing, it tell me what I should be doing, and I keep moving within basically my workout session. So I didn't find anything at the time, and then I went in December to the AWS conference in Las Vegas. They had talked about Nova 2 Sonnet, bidirectional speech, and I was like, hey, I think that's what I need. So I went down this journey of learning how to use it. Okay. So what's new in Nova 2 Sonnet? So Nova 2 Sonnet is basically videos, multilingual and polyglot. It's cross-modal input. So basically it does not just the actual conversational piece, but also produces a transcript of everything as you're actually talking. So you can actually see like what it's actually taking in as you're actually talking to. Okay. So it has turn-taking control. So it will actually pause. It'll wait for you to answer or speak back, and it'll basically come back. So it does all that. It does it automatically. You don't have to tell it to do it. It's built into the actual model for the actual people that. Async tool calling. Now, async tool calling is basically when the model needs to pull some information or basically push some information, it can call the tools. It does it asynchronously. But the great thing about it is that when it makes that tool call, it doesn't wait for the tool call to come back. It can continue on with the conversation, which makes it a lot more smoother. Just like the conversation that you're having with the actual assistant. It's not like Alexa, but basically you say, hey Alexa, you say something, it stops. You have to call Alexa again and say something else, and it stops. This is a real conversation between you and the assistant. So think about the application of that for customer service, for just somebody to talk to, as some people do like nowadays, turn their assistant into like their best friend and play. So, some real conversations you actually have. Now, I'm not going to say that it's perfect. There are some things that you have to basically think about and talk about because the async tool calling is non-deterministic, which means that you have to basically think about if the tool fails to get called, what do I do? Okay, so It doesn't do it all the time, but it does enough for you to actually notice it as you're actually going through testing and working with the actual model itself, right? But it's within the documentation. It's not something that you see and you go, hey, this is the bug. It's in the documentation that tells you it's not deterministic, right? It has a 1 million token context. Does everybody know what that means? Everybody know what that means? Good go. Okay. That means you can basically put, and it's not exact. It's accurate. They won't tell you it's exact. It's basically like a million words. It actually have that context. Okay. So it's huge. It's really big. I haven't ran into it yet, but I run into that limitation unless I basically just keep basically going and asking questions and doing things. But it's a speech model. So you do a million words talking to it in one session. You probably need to go find your foot. Right? It's telephony ready, so it can connect with Amazon Connect, Twilio, Bottage, LiveKit, and it's all built into it. It's not you having to basically compute that. Okay? Any questions on anything I just went over?
So I'm just famous get tired of this part about this conversation or something highly technical. But just broadly speaking, how do you translate that what it would to be outside of the time? How long of a conversation can you?
Glad you asked. It's actually usually in my presentation I explained that the connection is a hard stop at 80 minutes. So that connection that you actually have in let's do a WebSocket is 8 minutes. Now, it doesn't mean that you have to stop. It's just that you have to program around that. That basically, let's say 6 minutes and 30 seconds or 7 minutes, you have to basically reconnect back in the background, hydrate it with the conversation, probably pull it from your temper, and then basically give that connection there to use. So they don't see anything as long as you do it like it's delete. Right? It's one of the things I have to do with the app that I built because, as you know, usually the joke 45 minutes, an hour or whatever. So when I first started working with the dime, saying, hey, just calm down. It was breaking that, but then everything I had done was gone. So it's like I was starting. So you have to program it's I would say, it's not easy to do, but it's basically doable. You'll finalize comes up there for me. Okay. Let me ask you a question.
Yeah.
Okay.
How do you guys edit it? From the doctor, basically.
I started out browser based as far as like the application build for it. I started out with it, had a lot of fun with it. Basically, because I was doing it with my phone. So basically, when the phone would basically lock, then the web connection would drop. And so I basically had to build a mobile app, which basically has a back plug in. And then with the old mobile app, I basically tell the background and keep it. Basically, don't let the phone lock. Be safe sometimes. Now, I didn't know I had to do that. I'm used to Spotify. Basically, hey, phone locks, music lighting. Web connection, not like that. It's a security question. They still paused. So, you just think, I learned all that stuff. I'm a big guy. Did I answer your question? Anyone else?
Did you say you integrated this in telephony? Or
No, it's basically a mobile application.
So the model is basically it takes care of the entire conversation for you. So it's speech to speech, one model. It listens and speaks directly. No separate transcription, no separate LLM model, none of those things. Has anyone ever heard of the Cascade model? Okay, so the Cascade model was basically, you had one model basically did like the speech, another model did like the transcription, and then sometimes you'd have like a third model that basically takes that transcription, basically like the text to speech. So you had speech to text, text to speech. But you had to use different models to do that. If you're using Nova 2 Sonic, you only use just the one model to actually do that, okay? It's bidirectional, as I said. So it is you talking, the model coming back and talking to you. Now, the great thing about it is that, let's say the model's actually talking, you can actually barge in and it basically picks that up. And it says, hey, the user's speaking again, so it'll stop talking. Just like you would if you were talking to someone and they say something and then you kind of go, but and they stop. So the model does do that. And now for your application, when you're doing your application, you have to then make sure that you clear the buffer once that barging comes in, because the buffer still has whatever it was either talking about or you were talking about at the time. So you have to basically in your application clear the buffer out because the barging came in, and you need to basically then just have the system do whatever is natural for it to do at that time. It is built for agents, so it can call tools mid-conversation. And so spoken answers update real systems live. So this is not the tool calling and actually the actions that it takes. It's not something that happens after the conversation, nor is it something that like, hey, it takes 2 minutes for it to do that. It does it in real time, but it is asynchronous, so the conversation itself still continues as you're basically going through and having the conversation. Any questions on that? Everybody good? All right. So my production stack, what I run on AWS, I use Agent Core, Nova 2 Sonic, agents and orchestration. I've probably got now about 15, 20 AWS Lambdas that I actually run, because each portion, each tool that's called, I basically dedicated a Lambda to that. Since it's serverless, it's not like it costs me anything. And that way, if something breaks, I just have the one thing that I have to work on, and not trying to figure out in this big, ginormous, huge code block which pace it broke. Okay. I use DynamoDB for memory, because remember, models don't have a memory. Every session is new unless you've got something that tells it, basically you're injecting something into like the prompt, which context. So think about if you are, let's say like a customer service or something like that, and the user's calling in, they say their name, then the system can then say, hey, this is John P. It goes and basically pulls the information, the memory of the last sessions that happened, and it pulls that information into the context. So then the agent actually knows who they're talking to, what are some of the past issues that John has had. So all those things basically come from the memory. So if you don't have a memory, this is short-term and long-term memory, the agent has no context other than something you give it, which is basically then is very general and it's not personal. Okay? And then I use Cognito, EventBridge, and CDK. So I use Cognito just for the authentication. Within the actual app itself that I'm using, I actually have put in like biometrics, so now it's just putting a thumb on it. But that's pretty much kind of like my stack. There are a bunch of other things that go along with it. There's like a finite state machine. And then I've got a couple of things in there, epochs, to keep the sync in between the finite state machines. But this is pretty much most of the stack that I use. The production voice loop. So on the actual incoming opening session, when you're actually talking, that feed has to be 16 kilohertz, basically going to the model. It has to be that. It can't be anything else. If you do, basically it'll just break. All right. That's something that comes from AWS, and that's just how it works. You've got the authentication, and also once that's done, then it basically the WebSocket gets opened and goes from there. For the second part is basically the runtime of the agent, which is just Agent Core holds the socket, and then how the decisions are made. So you can use different things, land graph, whatever you want. And then Novasonic 2 plus memory. So as you see, when it comes basically back, so it's going to go 24 kilohertz and also with the memory. Okay. That's just a simple loop. This is some basically just kind of the hard problems. One is like the barge in, just like I said, you have to drain the buffer when the barge in actually happens. The other is the coordinating state. Now, I will say, when I was building stuff out, the finite state machine, the coordination, the making sure that things stay in sync has been the hardest problem that I basically had to figure out. Because you got to think you're going from, let's say, a mobile app. If there's a tool call, goes to the server's coming back. The user is probably still talking. So then there's something coming back and it doesn't know, hey, what state am I in? Like, am I still in there waiting on the tool call? When the tool call comes in, am I supposed to serve it up? Like, where am I at? And so one of the things I ran into was I had a finite state machine that I had basically on the mobile app, but there was nothing on the server side to basically tell it, hey, this is where we're at. There was nothing to tie those together and sync it. So I had to figure out what's basically called an epoch, which basically is like the package over the top that says, this is where I am and I'm at this time. So then when basically the packet hits the server, if they don't match, one gets dropped and the other is said, this is the true time, and it basically resets itself and refreshes itself from the server as to where it's at. So that portion, the coordinating state, I think within the documentation, there wasn't a whole lot about it, but as you start working with it, you do find it, but it's not something that you'll see in a lot of the examples because it's not a full built out app. It's usually just samples. Hey, just showing you how it works. But the hard part is basically building the application and basically the infrastructure and the layers to support it. The 29-second timeout on the API gateway. So that bit me a couple of times, but it's just a 29-second hard cap. That's just basically what it is. You work around it. There's a lot of examples out there about it, how you work around it. It's not a big deal. It's just when you run into it, you're kind of going, what the heck's going on? So the usual stuff. Mobile socket drops, screen lock, backgrounding, kills the WebSocket mid-session. So mine, it basically just had to keep alive in the foreground. Now, some of the things I ran into was depending upon the model that you're using, if it's an iPhone or if it is Android. The security features are different things you have to basically look out for. I use mostly just an Android, so I basically have to tell it, hey, allow it to do this. If not, then the security feature on the phone will actually kill the app. Okay. The 8-minute session cap, like I said, it is a hard 8-minute cap. It's just what it is. You just have to figure out how to get around it. How I got around it was basically at about, I think it's right around 7 minutes. I basically build another connection in the background. I then hydrate that new connection with anything that's happened during that session, any memories and stuff that needs to go in the context of that. I inject it into so that then when I surface the new connection, everything is still smooth. The user never notices anything because everything is in the new connection. And as long as you've got that and it works fine, I've gone like an hour and a half and everything's gone just fine. Remember, the context window is like 1 million. So there's really no way you to kind of like, unless you're doing something completely different. Now, there probably is a way for you to go past that. For me, I haven't run into that issue at all. And also there are ways that you can basically compact the context. So basically take out a bunch of filler and stuff. So then it's not as much that you're actually putting into that reconnection. So you can do that. Part of the things I do right now is every Saturday I have a job that runs in the background and it goes through and it compacts the memory. So then it reduces the footprint that's actually in my DynamoDB database for that. So I do have it do that. And it's recommended that you do that. I think some people do like 30 days, whatever. For me, and basically what I'm trying to do, I just have it do it every weekend and it basically compacts it. So the long-term memory is compacted. The short-term memory is just at what you're doing right now at that point in time. So we've done a lot talking about memory. We've already talked about LLMs reset every session. My background job just got through talking about that. The biggest thing I want to point out is when you're looking at doing like a voice model, if it's something where it's like it's going to be interacting with your users, make sure you think about the user experience and also making it a personal experience. Like we all have worked with Alexa and things of that nature. So, but for this particular model, because it's bidirectional, the other thing is that it does different languages, it does different voices. You can put in them as context as you want. You can have it just like any other agent connected to knowledge bases. research, all that stuff, is think about the experience of the user. One of the things that I know a lot of times we get caught up in, especially technologists, is the tech. What I built is so wonderful and great. But if the user doesn't like it on the other end, it doesn't matter. You can have all the bells and whistles. If the user thinks it's a crummy experience, it's a crummy experience. And most people will gravitate toward a more personal experience, and they'll pay more for a personal experience. That's why you get a personal trainer as opposed to just going to the gym. And the better that experience is with that trainer, the more you'll pay, because you'll say, well, Paul is the best. Because he makes you feel like you are really doing something. You're actually working out and doing something. So under the hood, one of the things that you will see in an example, there's an example out there in AWS that basically says you can inject a greeting before you start the actual session. No, you cannot. I can tell you that from experience. The model will reject anything that's not basically the user starting the conversation. The user has to start the conversation. It is something that the model actually looks for. If you send it in and it basically comes from the system because it gets tagged that way, or anything outside of the user, it will reject it. You may get it to work a couple of times, but 90% of the time it's going to reject it. So the user has to start the conversation. So what you can do is basically prompt the user to say, hey, Paul, whatever the assistant name is, waiting for you to speak, start the conversation by saying hello. And that will basically start the session. Anything that you try and do outside of that, it is going to reject. Okay. Now, that goes into also because you'll want to build a test harness around it to be able to test stuff instead of you having to do it live. So there are ways that you have to figure out how to test it. And I started using like Amazon Poly and things of that nature to kind of help with the testing to build a test harness. Because that's the only way you can test it. Unless you want to sit there and test it all the time, and that's just not scalable at all. All right. The streaming is both ways. So like the user starts, audio input. There's also a transcript that comes out. So one of the things that I've done is to make sure that everything works the way it's supposed to work. And I know that one of the things was trying to get the tool call to work is the model will actually say it's calling the tool. It'll put it in the text that it's calling the tool. You'll find out the tool didn't get called. So if all you're going to use is basically the model saying that, yes, it did what it's supposed to do, you have to go and check it. Remember, the tool calling is basically it's non-deterministic, and it also the model decides when to call the tool. No matter how much you put into the prompt, every time you do this, call the tool, it may not do it. So you have to basically look at a way and kind of design around when it doesn't do that, because it could be just because it didn't quite understand what the user said. So it didn't pull or get triggered by a tool call. So one of the things you want to do is basically look at it and see how do I build around that? And it's actually within the AWS documentation. It's not something that they're saying it does do it all the time. It says it in the documentation. And so you have to make sure that you're looking at it, you're testing it, and you're trying to design around it as much as you can. So what I've basically done is I use Nova 2 Sonic for the bidirectional voice, the conversation, the context, making sure the user understands it, and also then look at how can I capture the tools, like the tool calls, and make sure those work. So you have to kind of design around that, all right? And basically the tool calls, so I basically went through all that. So one of the things I talk about is just forms lose people, conversations don't. So if you have an organization and you guys have like a long form or something like that, look at something like this model that works, like I said, extremely well to kind of help to personalize the discussion with the client. You can do it using a web, you can do it doing a mobile app, either way you want to do it, but it works really well. And it does give people that feeling of they feel like they're actually talking to somebody. One of the experiments I did with mine was, so I created it, and then I basically had my 14-year-old daughter test it. So she looked at it, she listened to it, and she was like, Daddy, that sucks. So we worked on like the voice, the prompt for how to set up like what I wanted the agent to be like when it's doing the voice. And basically when she was like, I like that, that was good. And so it was an experiment with her because for me, I knew what I wanted. So I'm looking at it going, sounds just fine to me. But it's other people when they test it, that's when you'll kind of get the feedback that you want. Hopefully you guys learned something. Hopefully you enjoyed the presentation. Thank you.